Hi everyone. Let's start lecture 2, which is about Introduction to Descriptive Analytics. This lecture will be presented in 3 parts, and this is the first part. On the course map, we're still in introduction part. We just completed the first section here, the first lecture, which was about introduction to analytics. And in this lecture, we are going to have an introduction to descriptive analytics. Okay, what's descriptive analytics? In descriptive analytics, we want to describe our data in the forms that can be grasped and understood by our audience. So it could be in graphical or numerical methods. If we use a graphical representation of our data, I mean, we are going to summarize our data in some graphics. This is called data visualization, and we will cover this later in a separate lecture. In this lecture, we are going to focus on numerical methods or summary statistics. Okay. In summary statistics, we have 3 categories of measures: central tendency measures, measures of position, and measures of variation. In central tendency measures, we have 3 measures: mean, median, and the mode. Okay, and in measures of position, we calculate percentiles and quartiles. And in measures of variation, we have different measures like the range, variance, standard deviation, coefficient of variation, and interquartile range. So let's go through the details of these measures. The first measure in central tendency measures is the mean. Here we are going to represent the whole data set by a single number, which is the average or the mean of the data set. Let's assume that we have a trading strategy in a stock market, and we have applied that trading strategy on a stock for a period of time. So here we have a data set, and that data set shows the performance at a time over that period of time. So we can take the average of the performances, and that single number can show the significance of the whole. I mean, what is the average performance of this trading strategy? And for example, if we have different trading strategies and we have applied those trading strategies at the same time on the same stock, then we can compare the performance of those trading strategies by the mean, right? Yeah, the mean here can be a base to compare different data sets. One of the disadvantages of the mean is the impact of extreme values. So for any variable, it is possible to have some extreme values, right? But we know that the frequency of those extreme values is pretty low, so they are rare to happen. But if we have some of those extreme values in our sample data, then those extreme values are impacting the quantity of the mean. Okay, and instead of calculating a simple mean where the different data or different observations uh, do not have equal weight. In that case, we need to consider weights, and we should calculate the weighted mean. And in that case, that they are not equal in their in that defined weight, then we have to go with weighted mean because it's more accurate than the simple mean. Okay. The second measure here is the median. The median is the point that the half of data are above that point and the half of data set are below that point. So in order to calculate that, we can first sort the values in ascending order, and then the middle value which divides the data set to 2 equal parse. I mean, half of data above that and half of data below that. So here, that point will be the median. So when the number of data values is even, then we take the average of the two values in the middle as the median. Okay. And one of the advantages of median compared to the mean is not impacting by the extreme values. Okay. And the third measure is the mode. The mode is the observation which has the highest frequency. Okay, so and it is easy to calculate, and it's not affected by the extreme values, same as the median. And we may have more than one mode in a data set. So if we have just one mode, then that data set is unimodal. If we have two modes, it is bimodal, and if we have multiple modes, we call that as multimodal. So some data sets may not have a mode. They are somehow uniform like this. Okay, I mean not perfectly uniform, but like something like that. We call this as approximately a uniform data set, and we say that there is no mode on that data set. And if we have multiple modes, then maybe that measure is useless. I mean, the mode is useless here, because when we have just one mode, or let's say two modes, it is meaningful to consider that as an input for our decision making. But when we have more than two, or somehow a uniform, then this measure would be useless in that case. Okay. When the data are symmetrical, like a normal distribution like this, for example, then the mean, mode, and the median all are in the same place. They are equal, okay, for the symmetrical data set. But when the data are not symmetrical, then the mean, median, and the mode are not located at the same place. So in that case, our the shape of our distribution, I mean the distribution of the data, could be right skewed or left skewed. Okay. When the data are not symmetrical, then they could be left skewed or right skewed. In the left skewed, we have a shape like this. Okay, so you see here, it's tailed to the left, and we also call this as negatively skewed. So in this case, let's say here is the mode, and the median would be somewhere around here, the median, and the mean would be somewhere here. So as you see here, the mean is less than median, and the and also mean is less than the mode. Okay. And if it's right skewed, it will be like this. Okay, and again, as you see here, the mode, it would be here, and the median and the mean could be somewhere here. And in the right skewed, we have the mean is greater than the median, and also mean would be greater than the mode. So we call these shapes of distributions as left or right skewed. Okay.